In this example, we're writing a linked int list class. This is similar to our ListNode class, and it's also similar to the array int list class for arrays. To do this, we need to think about how many fields we need, and we can get any element by simply having the front of the list, the very first value of it. So all we need really is a list node that is dedicated to the front. So we can make this private, list node front. And the reason why it needs to be private is because with list nodes, it all depends on the front value. If you lose any value, you lose that part in the list entirely. There's no going back to it. So it's important to encapsulate it so that nothing can delete this list. Earlier we had this while loop that we made in our example right here. We had this while loop, and what it did is it made a temporary list node that equaled the list that we were looking at, and we went through each of the nodes and printed them out. Well, we did that in a main method, but if we do it in a class, it simplifies the amount of work that we would have to do in the method, or in the main method, if we just make a method inside of our class. So writing this out, this will be a replacement for the loop. So this is, we can write replacement for a loop, and we can make it public and make it void because it's not returning anything, and call it print. The reason why it's okay to make this public and not this public is because print isn't changing anything. If anything happens in print, it's going to be okay, because we just don't want any outside code to change our front of the list. That way we can't lose our list. And after we have this method, we can basically write everything in here inside of our method, so we don't have to write it in our code right here. We write list node current is equal to front, and again this is making a new instance of list node. It's calling it current. This could be any name we want, but current is standard, and we're setting it equal to the front of our list node. And we're going to have while current, we'll do .next does not equal null. We sys out current .data, and current is equal to current .next. In our while loop, we see it's the exact same thing. It is important to note that for our public class linked int list to work, our public class list node must work, because this is what's storing data, and we are using data here. We're also using list node. We're going off of the list node class to make this linked int list. Also with arrays, we have a toString method, and although we can print this out like this, it would be easier just to call it by toString. What we can do is make a, well, we can title this toString, and we can make a public string, and if we title it toString, and we need a return value for this, but for now we can just have it return null since we're using this as an example, and you see the error clears. If we go into our normal code and we want to call this, what we would do is we would make a new instance of the class. So we would have linked int list, and we would call it anything we want is equal to new linked int list, like this, making a new instance of it. We can do test dot, and then we can see everything that we can do inside of it. We can look at our print method. We can also have our toString method, and these will go into those methods and run the code that's in them. So we have these, and it's the same methods that are in our linked int list class. Looking at our toString method, we can complete it now we can get rid of that null. We're going to have our if statement if front is equal to null. We're going to return brackets like this to signify that it is empty. This is the same thing as when you do a toString and it returns, if it's empty, it'll just return brackets just like this. So that's the equivalent here. And if it's not empty, we'll have an else statement. So that'll take in everything else. And we can make a string and title it result and set that equal to a bracket. Because when we have an array list, if we output it, the output's gonna look like this. If it's empty, it's just gonna have brackets, and if it has numbers in it, it'll be like this. So we need to have our output look like this. What we're gonna do is we are going to string result and store, we have our bracket, so that's good. We have our first bracket, but we also need the values 1, 2, 3, 4, 5, 6, or whatever is being passed through. So we're gonna do front dot data. So we're referencing the front of the loop, and from our ListNode class we are getting the data from each node. Front dot data, just like this, and that is going to be the first part. We can make a new ListNode and title it current and have it equal to front dot next. What this is doing is it's storing our next value in our ListNode. Our result stores a bracket and the very first value, front.data. ListNode current is a temporary ListNode that is going to store all of the values from front.next onwards. For the numbers that we have here, front.data is equal to 1, and front.next is going to be 2, and everything after that. That's what's going to be stored inside of current. From here, we can make a while loop to go through and put all of our elements into our string. We'll have current, or we'll have while current does not equal null, and we're going to have result. So we're basically going to be adding on to this, right? We're going to have result plus equal and then a comma. So we have to make sure to add this comma. We have a space, so we have to have this space plus current dot data. And then we have to go through all of our values. So we're going to have current is equal to current dot next. What this does is it allows us to move through our list node and store it into our string. So we already have this bracket and our first value inside of our string. This is what our string looks like right now. It is bracket 1. With our while loop, what we're doing is we are storing a comma and the next value of current dot data. We're storing the very next value. So, and we are adding on to result. We're not replacing it. If we were to replace it, we would make this equal, but we're not replacing it. We're adding on to it. And so what this does is it takes what we have and then it adds this to it. And then now, after the first iteration of this while loop, it's going to be bracket 1, comma 2. And after the second iteration of our while loop, it's going to be bracket 1, 2, comma, space 3. And then the next iteration is going to give us this, and then this, and then this, or actually, yeah, it'll give us all of that. And after it gives us all of that, what we can do is, I think this actually has to be current.next does not equal null. If not, we can always correct that later. But we're still missing our last bracket here, and we can't put that in our while loop, otherwise it'll have a bracket every single time. So after our while loop is finished, what we're going to do is result, and we're going to add to it, we're going to add a bracket to it just to finish it off like this. And then we are going to return everything that we did, which would be result. Just to summarize, in our if statement, we're checking if the front of our list node is null. If it's null, that means our entire list is empty. So we're just going to return brackets. In our else statement, if the list is not empty, we are going to go through these steps of code. And in our first string result value, when we assign result this, we are going to get this. We're going to get a bracket and 1. And that's what, because our goal is to have this type of string, something that looks like this, if these values were in our linked list. Now we need to make a temporary list node to store all of our next values so we don't mess with our main list. Now we need to make a while loop to add in all of the values. In our while loop, we're going to have it running as long as current.next does not equal null, and we are going to have the result. So we are going to have this part right here, and we are going to add onto it. So after our first iteration, we are going to have, well, before we go into the loop, this is what our result is going to look like. And then after we go into the loop once, it's going to be like this, because we need to add a comma, a space, and then our current value. And then we're going to do the same thing until we have our next value, which is null, and then that's going to output 6. And this is just incrementing the index of current to get it to null, so the loop breaks. And then once we have this, we actually don't have a bracket here. After our while loop, we are going to put the last bracket in here so it looks like this, and we need to add it to the result value, and then we're just going to return the result value, and that is our toString method. There are some things to make this code cleaner a little bit. Instead of having this on a different line than this return statement, we could have this be on the same line like this. And also, if we wanted to, if we look at our replacement for the loop in our print statement, what we're going to do is how we made our temporary value, the list node current is equal to front. When we made our temporary value, we didn't have anything in front of it, but for here we have something in front of it. We have a bracket because we need a bracket, and then we have front.data with it as well because it's easier to just have it in there for convenience. However, if we wanted to, instead of having it as front.data right here, we could take that out and have it end there, and then do front. We could just have current is equal to the front linked list, and that's basically the same thing. It's just starting from the value 1, whereas when it said front.next, it was starting from the second value, and then we just had the front.data with the string. There's only two differences. They're kind of small, and having it like this or the other way doesn't really matter.